Hi everybody, good evening. Welcome to my YouTube channel. Please keep subscribing to my videos. I'll be coming up with new topics uh, on industrial system, mechanical engineering and technology, CNC programming, SPC, APQP, and the related things to quality planning, quality tools, etc. So please do not forget to press bell icon. Uh, you'll be getting more alerts on these topics. So today I'm going to talk about the uh, Kaizen format, which is being widely used in industrial systems and manufacturing industries. Let me check and let me explain what exactly the Kaizen format is. You might have heard, the professionals who are working in industries might have heard of this and implemented this. So I'm going to explain and fine tune the clarity of that. Do you know what is Kaizen? What exactly it is or what it means? The meaning of Kaizen is continuous improvement. The Kaizen, the word is derived from the Japanese language. It's a Japanese term. So does any company require it? Yes, obviously it will require. What exactly is it? It's a combination of problem and improvement. It's a display of problem and the improvement. So here, if any problem occurs, the steps are: problem has to be analyzed, for that solution has to be found out and to be implemented, and it should not be stopped there. The improvement should be continued the improvement. So this overall summary or the picture will be given by Kaizen format. So Kaizen is nothing but continuous improvement. So let us understand it. So, and to know what exactly the format tells or what exactly the format contains, so let us look into the format in the next slide. So this is one of the format. This format is implemented in my earlier organization. I'm going to explain about each of this content. I divide this into three sections. One is the areas or the categories or the fields where Kaizen is going to be implemented. Next is what is the picture of before and after, and what are all the remedies or the disadvantages associated with these things. So let us get into the first section, that is the fields. So improvement should be implemented in safety, delivery, quality, cost saving, housekeeping, transportation, overproduction, motion, walking, defects, waiting, inventory, and processing. So this improvement has been found in quality, defects, and processing. So same thing has been highlighted here: quality, defects, and processing. So let's go to the second section. So the pictorial representation says what was the conditions before and after. Here the problem is block cutting was not proper, and it was the block cutting was improper. So the block was cutting in the cross direction. What do you mean by the block? So I'll give the small explanation of pleating paper. Pleating paper is a waved paper produced by the pleating machine. So it has got certain length. So that certain length has got is termed as a block. So this block is after it is glued together, first and last end it's glued together, it is going to be fitted in the filter mesh. The ultimately filter mesh is going to be fitted in the diesel engines. The major issue or the importance of this filter paper is it is the filter paper which purifies the air and gives the pure air to the engine. So here block has to be cut properly. It becomes two ends. When the two ends are cut, they must be again closed together and glued together. The problem here is when the pleated paper is inserted below this with before cutting, it was not going properly. You can see this picture. There's the platform here on this machine. It is going to be pleated paper. One of the slot is going to be inserted in this gap. So this plated paper extrudes or projects beyond this platform. So what was happening? It was getting tilted inside the machine itself. So because of this, when the cutter comes and cuts this plated paper, so because of its slackness and there is no stability in the paper, it was cutting slantly, or it was not cutting the uh, paper uniformly. So because of this, what was happening? So I'll come to the disadvantages section. Quality issue, mismatch after first and last pleat operation, where when the two ends are created, this has to be closed together. Cutting along the pleat height direction was not proper. So then pleats were getting uh, ununiformly cut. So this is the problem. So I'll go to the after section. So after, what has happened? We generated an idea. So a block has to be provided beneath the platform of that machine. So this should be in such a way that when the plate is inserted, it should be guided properly and it should go straight. The same thing has been made with a gap of 12 mm, and this height is also 12 mm. So it has got normally 34 mm of height. So this 12 mm is sufficient to hold it or guide it easily. Before, the condition was only 3 mm the platform thickness is. So there is no more area to get slanted. So almost the 50% area of the pleat height was covered by that guide block. So after this improvement, there was no cross-cutting uh, problem has occurred. Guide block has been introduced in the slot of block cutting machine. So because of this, we found advantages and the remedies. No cross-cutting is occurring. Pleats are guided properly in the block. This was the expected results. So this responsibility, who holds the responsibility, was process department and production department. Process department implemented and production department has to continue and look after it. Then effective date was is given. So implementation cost was so and so rupees, verified by and team members and approved by. All these things are given here. Similarly, who has implemented or who has prepared this format and belongs to which department, which division, all these things are included here. So, and number of the Kaizen number is also mentioned over here. It's a simple format which displays or which explains what was the before condition, what is the after condition, what is the problematic condition, what is the improved condition. I'll show the other format of the Kaizen also. This also says what is the before condition and what is the after condition. Here I'll explain about what is the problem. The category belongs to safety, chips clogging onto the work support of the OP40. So there is a work support here. You can see the chips. Chips means the burrs produced due to the machining because of the removed uh, particles of the material. Curly chips were being produced during the cutting or accumulated in the V block. This is called the V block because it is in V section and threaded portion interface. Chips were very difficult to be removed by team member or the operator. It was very time consuming. So chips were entangled in the threading operation. Because of threading option operation itself, it was getting the chips were getting generated and it was getting stuck in the in this interface. So as per the observation analysis, component support if it is referenced from non-plane surface. Here the surface is non-plane because it has got a thread formation. It is not a plane. Chips will get entangled with block and component. So a new idea has been generated after the Kaizen concept. Change the supporting block to the planar circular surface. So this should get shifted to this area because this is very plain area. V block supporting position changed on to 43 OD. This diameter of this plane surface is or OD is 43 mm. So next, the picture is this. The V block has been simplified in such a way that it easily fits or supports to the diameter 43 OD of a steel material. This material V block design changed to Y shape. The space was reduced and there is no accumulation of this burrs. Henceforth, no need of removing chips. So what was the conclusion? For turning between centers or between the chuck and center, support block should have planar contact surface with that of that component. So the signature has been done, it has been approved. I'll go to the next one. Category is 4S. 4S means cleanliness, theory, Seton, Shikatsu, Shitsuke. So then the title is Kaizen work. No proper identification of the coolant level. Though this visualization should be proper. Here, no identification of coolant level in this particular operation. No visibility of the coolant level. Coolant level detection sensors are available but are not indicating the coolant level details properly. So it has been again further improvised after the Kaizen. What has happened? A display figure has been given which gives the details of the coolant level. So what has been made? A label or the plate has been installed, which has been zoned as red, yellow and green. Green depicts the optimal zone of the coolant level from 35 35 percentage to 85% of the coolant level in the coolant bed. Next, it shows the red alert when percentage is 0 or when the coolant level is literally 0 to 10%. Then 95% to 100%. When the coolant level is too high, then also machine stops. So optimal zone is 35% to 85%. The details, everything has been given here in a in Excel format, in the table format. So again, two sensors have been positioned so that it indicates what is the red level or what is the critical level. Two sensors indicate coolant level 1 and coolant level 2. Upper sensor indicate coolant level warning, higher coolant level warning. Lower sensor indicate coolant levels, lowest level reached. So this is the improvement has been made. It is clearly uh, reveals what exactly has happened. This is a very simple format. It can be applied to any of the system, even in the home system, or in the industrial system, or wherever it can be done. So this can be applied anywhere. So it has been approved. So you have to continue to do the improvements. So always there will be a problems even after the improvement. So you need to keep on improving the conditions. Yes, thank you. Thank you for watching my videos.